All right, welcome to Chapter 7. So we're looking at 7.1, which is converting temperatures. Okay, so the different temperature systems that we know of, and hopefully you've heard of them, are Fahrenheit and Celsius. So Fahrenheit is what America uses, and Celsius pretty much everyone else uses, if I am correct. Americans like to be different. All right, so both Fahrenheit... Oh, this is supposed to be and Celsius temperature scales are used in healthcare settings. So it's very important that a healthcare professional must be able to convert accurately between these two systems. All right, so you need to be able to convert between these two because they are often used. So example 1, look at the two thermometers below to answer the following questions. All right, so we have these two different thermometers here. We have Fahrenheit and Celsius. So, actually take a moment, pause the video, and see if you can go ahead and fill this out by yourself, and check back in with me in a second. Alright, so at what temperature does Fahrenheit freeze? Well, we're going to go ahead and just read the diagram. Water freezes at this point. So, first, let's see, for Fahrenheit, that's 32 degrees Fahrenheit. So we're going to go ahead and write the 32 and then degrees Fahrenheit. And remember, that's a capital F. We do not use a lowercase f to indicate Fahrenheit. And then, at what temperature does Celsius freeze? Well, going over here, that's going to be 0. So 0 degrees and then capital C for Celsius. All right, part C. At what temperature does Fahrenheit boil? So we're going to go ahead and continue to read the diagram, looking for boiling temperature, which is right here. And boiling temperature for Fahrenheit is 212 degrees Fahrenheit. And water boiling at Celsius is 100 degrees Celsius. To me personally, Celsius just looks a lot less complicated to memorize, now that I think about it. Okay, so here we go. Moving onward. The main formula for converting between Celsius and Fahrenheit, or at least the first formula in our book that we are introduced to, is equation number 1. So 5 times degree Fahrenheit minus 160 equals 9 times degree Celsius. So in the formula, degree Fahrenheit represents temperature in Fahrenheit, and degree Celsius represents temperature in degrees Celsius. Okay. There are other equations. So we have equation 3 and equation 4. That should not be equation 3 and 4. That should be equation 2 and 3. Somehow I got that mixed up. So please go ahead and change that on your notes. Those should be equation, going through all the different steps. I should just use the eraser. There we go. Look at that. I'm learning how to use the eraser. Okay. I'm going to go ahead and edit my error here. Oh, look at that. Alright, changing pen size. And we're back. So equation 2 and equation 3. Alright, so equation 2, we have this lovely formula here. And then, so one thing about equation 2, notice it is solved for degrees Celsius. So best to use if we're going to input a Fahrenheit degree to get Celsius. So if going from Fahrenheit to Celsius. This one, on the other hand, is solved for Fahrenheit, and you would input a Celsius. So this is best to use if you're going from Celsius to Fahrenheit. Notice our original equation at number 1 up here is not solved for either one. We're not solved for either variable. Alright, so let's go ahead and use, for example, 2, equation number 1 to convert the following. 98.6 degrees Fahrenheit to degrees Celsius. So the first equation is 5 times degree Fahrenheit minus 160 equals 9 degrees Celsius. And we're going to go ahead and input 98.6 where we see Fahrenheit, which is right there. So you could go ahead and pause the video and try to solve this and check back in with me. Alright, let's do some calculating here. 98.6 times 5, 493, minus 160, 9 degrees Celsius. So 493 minus 160 is 333. Carrying on over here. Okay, let's go ahead and divide by 9 to get the degrees Celsius by itself. Is 37. All right. And there we go. So moving on to the next page, part B. So same equation we're going to use, but this time we're going from Celsius to Fahrenheit. Okay, so let me go ahead and copy down my equation. One thing for the exam, please note that you need to copy down the equation you're going to use before you start using it. Okay, so for example, note how I write out the equation before I fill it out. This is to let me know which equation you're planning on using for the problem. So we're going to go ahead and input 100 right here where the C is for Celsius. So 9 times 100. I know how to do that one in my head. Okay, let's go ahead and add that 160 to both sides. Gotta be careful with that little degree next to the 5 there. You could start ending up looking like a 50. Okay. I'm going to divide both sides by 5. That should end up being like 210 or 212 or something. Let's see. 1060 divided by 5 is, 212. How did I know that? Well, because, ooh, that looks hideous. Remember, 100 degrees Celsius, that was the boiling temperature. And I know that 212 degrees Fahrenheit was also the boiling temperature. All right. Now example 3, we're going to use equation 2. So what is equation 2? I'll go ahead and copy it down. Degrees Fahrenheit minus 32 all over 1.8 equals degrees Celsius. All right, so we're using this to solve for Celsius, and we're inputting 9.8 for Fahrenheit. All right, go ahead, pause the video, try to solve by yourself, and check back in with me in a second. All right, calculating this out. $37. And I believe that's supposed to be the human body temperature. So normally the human body is about, I think that's 98.6, I might be wrong. Okay, so that would be it in Celsius. All right, so let's go ahead and we're going to convert this time. Oh, interesting. Look, 37 degrees to Fahrenheit. So if we do this correctly, we should actually end up getting 98.6 because we're just going right back. Let's see. So we want to go ahead and convert from Celsius to Fahrenheit. So we're going to use this equation, which once again I will copy down, as you should do on your exam notes, to let me know which formula you are using. And we're going to be plugging in 37 right here at the Celsius. Okay, once again, pause the video and check back in with me in a second. 66.6 plus 32. 98.6. And is that what we had before? Yep. Okay, so it makes sense. Look, we got the right answer both either way. Alright, so once again, easier to use equation 2 if you're solving for Celsius, and equation 3 if you're solving for Fahrenheit. Alright, moving on. Converting time. Okay. As usual, there are different ways to do things. So, for converting time, many healthcare facilities use a clock with 24 hours on it, also known as military time or military international, or 24-hour time. Alright? The conventional time uses the 12-hour clock, so that's how most of us tell time. You know, like 1 o'clock, 2 o'clock, 3 o'clock. And is a source of errors in administering medication. So here's a quick question. Why do you think a 12-hour clock might cause errors in a healthcare facility? Can you think of an example? Okay, go ahead, just pause and think for a moment why there might be problems. Well, here's an example. Let's say you see on a chart that a patient needs their medication at 1 o'clock. Now you pick up this chart, and if you pick it up at 1 p.m., or if you pick it up at 1 a.m., do you know which one it was? Is it 1 o'clock p.m. they're supposed to get a dose, or is it supposed to be at 1 o'clock a.m.? There are 2 different 1 o'clocks in every day. In fact, there are 2 different everythings every day. There are 2 different 11 o'clocks every day, 2 different 12 o'clocks. There are 2 different 1:35s. Basically, there are multiples of every time. So I'll write this down. There are multiples of each hour / time. So it can be confusing which hour you are talking about. Alright, my messy handwriting. Okay, so the 24-hour clock bypasses the opportunity for error, which is really nice because you wouldn't want your doctor giving you the medication at the wrong time. That doesn't sound great. And you wouldn't want to give an animal the medication at the wrong time. It could cause some serious problems. As each time occurs only once per day, so that's the main perk for the 24-hour time. So, see the below clocks for AM hours and the PM. So these are the AM hours, and these are the PM hours. And I'm sure most of you have probably heard military time at some point. Alright, so moving along. When you're writing using a 24-hour clock for time, first things first is you're going to write 00 as the first 2 digits to represent the first hour after midnight. Okay, so for example, if you're talking about, like let's say it's 10 minutes after midnight. Since it's after midnight, you would do 00 and then 10 for 10 minutes after midnight. And then you'd write 01, 02, 03 as the first 2 digits to represent the hours 1 a.m. through 9 a.m. So that's all the morning hours. And then add 12 to the first 2 digits to represent the hours p.m. So those are the afternoon hours. And you write midnight as either 2400 or 00000. 000. All right. So we're going to convert the following to 24-hour time. So looking at A, that's going to be an AM, so I know I'm not going to be adding 12 to the first digits. Well, all I'm going to do, looking at the first part, is step 2. We're going to write 09. So we have 09, and then how many minutes do we have? Well, just 100, so 09, 100. And there we go. All right, looking at B, let's see, that's 12 a.m., so that's in the morning. So we're going to look at step 1 here. Write 00 or 00 as the first 2 digits represent the first hour after midnight. So 12:19 a.m. is 19 minutes after midnight. So it's just going to be 0019. 19 minutes after midnight. All right, and then C. Okay, so we're looking at 4:28 p.m. Okay, p.m., that's going to refer to step 3. We're going to add 12 to the first 2 digits. Okay, so what are my first 2 digits? My first 2 digits are 04. Okay, so that's going to be 12 plus 04, which would just be 12 plus 4. And that's going to be 16. So I'll go ahead and write 16, and then I will take my minutes and plop them here. That's going to be 16:28. Okay, so the best thing to do when converting, first look if it's AM or PM. AM is nice, you don't really have to change too much. PM is when you have to start adding 12. Okay, so now we're going to convert from 24-hour to 12-hour. Okay, so converting from 24-hour to 12-hour, the first thing you want to do is check if the first digits are bigger than 12. Okay, that's sort of tells us the time. If they're smaller than 12, we know that this is the AM hours. So less than 12 are the AM hours. If they're greater than 12, those are going to be the PM hours. And if they're greater than 12, what we're going to do is you're going to take the big number and subtract 12. But we'll get to that. All right, so let's go ahead and use our checklist. Is this bigger than 12? No, it's not. So I know these are going to be AM hours, which means I can actually just leave it as it is, 11:39 a.m. For B, though, let's go ahead and check those first digits. Those are 15. Those are bigger than 12. So I know this has to be a PM. How do I figure out which PM, though? Well, the plan is to take the number, take the first 2 digits, and subtract. What do you think it's going to be? 12. All right, so we're going to take 15, subtract 12, and we get 3. So this is going to be 3, and then bring down the minutes, the other 15, 3:15 p.m. So those are the minutes we brought down. Oops. All right, last thing to do is talk about how to say the 24-hour time. If you watched any military movies, you probably hear them shouting out military time hours. So the first step, say 0 if the first digit is a 0. I have also heard people say O for the first digit. So that would definitely be something to check in with the doctor you're working with, I would assume, on if they would prefer you say 0 or O. And then step 2, you're going to say 00 if the first 2 digits are both a 0. And step 3, if the minutes are represented by 00, then say 100 after you say the hour. Alright, so go ahead and see if you can write out how we would say these hours in English, and check back in with me. Alright, for A, well, the first option we might have, because we have that 0 there, would be 0. And then I see the 7, so that's going to be 7. And we have those double zeros at the end, so we would say 100. Or the other option would be 0700. And then for this one, similar idea happens here. We have that O in front, so we could say 0. And then we have the 9, so 09. And once again, the double zeros at the end would be 100. And, or, sorry, we could add 0900. So So for C, let's see, we have the double 0 in the front. So we're going to say 0, 0. From step 2 right there, 0, 0. 0, 0, 30. 0, 0, and then the 30 at the end. And then for D, so that's going to be 13, and then we have the 2 zeros left at the end, so 1300. And for E, well, we don't have any zeros in the front, but we have the 22. So let's go ahead and do 22. 22. Now this is interesting. We have that 0 there. So it should be 07. Or you could do 22, 07. If I'm correct, though, the more common way would be 07 or 22.7. But I believe it should be 22.07 is the most common way. And F, last one. So that's going to be 13, and there are no zeros to really worry about here, so it's just going to be 1331. And last one for fun, why not make up one? If we had 13 and this, we would go ahead and say 13, 3, 0. Alright, so there are some slight differences in how you could say it, but there's a pretty basic pattern. Alright, that's it. Please email me if you have any questions on Chapter 7.